All right. The video that I have before goes over the first part of this lab, the half-life of I-131 or the Penny lab. But I thought I would go through some of the questions in case there were any questions on it. So the first thing I wanted to mention is question number 4, or number 5 actually says, which of the curves, your data or the class data, most closely matches the theoretical curve on the graph that you made? I added these words in just to make it clear. So I want you to look at your own individual data that your team did and the class data, which is the average of everybody in the class and previous classes, and which most closely matches the theoretical curve, and answer why. Okay. All right. So then question number 7 asks, half-life is the time required for 1/2 of the atoms of a radioisotope to emit radiation and to decay to products. If you had 1 gram of I-131, how many grams would you have of the mixture of I-131 and xenon-131 after, oh, this is supposed to be after 16 days. Okay, so whenever I do analysis or calculations, I always want to use the number line. So I wrote the number line up here. And so I have 1 gram, 1.0 gram of iodine 131, and no xenon at the very beginning. Then after one half-life, I'm going to have 0.5 iodine and 0.5, because half of that iodine, half of that gram turned into xenon. So 0.5 iodine and 0.5 xenon. After one more half-life, I'm going to have half of 0.5, 0.25 iodine, but the other half of this 0.5 turned into xenon. So 0.5 plus 0.25 equals 0.75 grams of xenon. So the question asks, after 16 days, if you look on table R, the half-life of iodine 131 equals 0.26 days, right? So here's I'm just going to round it to 8. Here's 8 days. Second half-life is 16 days. So after 16 days, how much of iodine and xenon do you have? Well, that's 0.25 plus 0.75, and that equals about 1 gram. So it's kind of tricky there. So that's how you do that question. The next question asks, how long would it take for you to essentially get to less than 0.05 grams if you started with 1 gram of iodine 131, right? That's the next question. Less than 0.05 grams. All right, so we're going. We have 1 gram, 0.5, 0.25. Then we have 0.125 of the iodine, 0.06125. Then the next one is 0.03, etc. Right? So someplace between here, this area is where we're going to have 0.05. So one half-life is 8 to 16. 3 half-lives is 24 days. 4 half-lives is 24 plus 8, 32 days. 5 half-lives is 40 days. So if you said 40 days, that would be fine because you'll have less than 0.05 in 40 days. If you said sometime after 32 days, that would probably be okay as well. All right, so we just did number 7 and 8, right? 9 and the conclusion, I think, are more, hopefully you understood the lab and you can answer some of those questions. The post-lab questions, these 4, they're all using the number line. So if 50% of a radioactive element remains after 4,000 years, what is the half-life? So you want to use the number line. All right, so I start out with the amount 100%, right? And after 1 half-life, how much do I have? After 1 half-life, I'm going to have 50%. Okay. And it says that it takes 4,000 years to get down to 50%. So what's my half-life going to be? Similarly, for example, the next question, if 25% of a radioactive element remains after 1,000 years, what is the half-life? So I go 100, 50%, 25%, 0, 1 half-life, 2 half-lives. I'm at 25% at 1,000 years, right? How long does it take me to get to here? If this is 1,000 years, how long will it take me to get to here? You can answer that question yourself, I think. All right, the next question, number 3, says that the half-life is 1,250 years. What percent of the atoms remain after 7,500 years? So we start with 0. The first half-life is 1,250 years. The second half-life is 1,250 plus 1,250, which is 2,500 years. The third half-life is 1,2500 plus 1,250. That's 3,750 years. And I keep adding 1,250 until I end up getting someplace out here 7,500, right? On the number line. Meanwhile, on the top, I'll go 25%, 12.5%. That's after 3. Then 6.25%. I'm dividing it by 2 every time. This is after 4 half-lives, and so on. And keep going until you hit the 7,500 year mark, and that's where you stop and you read the percentage on the top, and that's the answer. Okay. Hopefully by this time you could do number 4 all by yourself. And that is the end of the lab.